Hello, welcome to this tutorial on the measure menu. If we go to the measure menu, we'll look at the following functions: line profile, area profile, circle profile and average line profile. Now these functions have also been created and are represented in a toolbox as these four icons here. So for the purpose of the tutorial I'm going to be using the icons rather than the measure menu. We'll start with the line profile function, and that's this icon here. Clicking on this icon, we are requested to, or prompted to, select an image and then to draw a line, and this line can be at any angle, and when I release the mouse we're presented with the profile, or the intensity profile, through the line. By picking up the green line we can drag it to a new position on the screen. Line and intensity profiles can also be applied to sequences of images or stacks of images. To do this we'd go to the line profile, and onto the image we would draw a line that we're interested in, and then we can use the play controls to move from one image in the sequence through to the next, and this is redrawing the graph each time we move to the next image. In the area to the right we're getting the statistics of the data associated with the line, and if we go to the view menu and open a statistics window we also get the full statistical data being printed out into the window, which when we move on to the next one will update, and at any time we can do a file save and save this data to a text file which you can then use for further analysis. Sometimes it's useful to be able to work with a calibrated coordinate system. To do this we would go to Measure, Calibration, and first of all we have to calibrate the system, and we do this by drawing a line onto the image. Now if we happen to know that the distance between the centre of the two eyes on this girl is 100 millimeters, for example, we can draw a line and then say the actual length of this line is 100 and the unit is a millimeter. So if we now draw a line profile on this image, we can use this to measure between two different points. I'll just stretch the window out a little bit more so we can see it. We can now see that that distance that we have on this green line, reference to the distance between the two eyes, is in fact 237 millimeters at an angle of just over half a degree. One can also see the statistics associated with the data along the line in the window. In the bottom right hand corner we've also got a little mini picture and a green line indicating the line that we'd originally drawn, and this can be moved by just picking up the line and repositioning the line at a suitable position on the picture. We'll now have a look at the area profile. By selecting the area profile icon we're prompted to select a window and then to draw a rectangular area over the image. What this has done is to create a histogram showing the frequency of events at different intensities. So what this is showing us is there's a higher number of dark or shadow areas and a higher number of bright areas, both of which are represented in the image. The circle profile allows us to extract the data around the circumference of the circle and then to plot this as an intensity profile. It's similar to a line profile but around the circumference of the circle. Again, we'll select the window that we want to draw, and this time I'm going to draw a circle. And what we'll try and do is to get the circle going through the girl's eyes. Now the circle profile starts at the 3 o'clock position and goes anti-clockwise around the circumference of the circle. So we can see here it's light to start with, goes dark as it goes into the eyes, light around the top, again dark through the eyes at coming up to 180 degrees, and then light for the remainder of the circumference of the circle. The average line profile function allows you to select a rectangular area on the image. I'll select the window, then I'm going to draw a rectangular area, and what this is going to do is to collapse the two-dimensional rectangular area into a one-dimensional array and then plot the data as an intensity profile. And this is particularly useful for improving the signal to noise ratio of the data that you have in your image. When it comes to analysing your images, it's generally better to use the OAS or odd area set functions available in the Image32 program. Odd area sets contain a number of odd area profiles, and these may contain either rectangles, circles, freehand areas or polygons. To enter a profile, one first selects the desired format profile, in this case a rectangle. We then select the window that we want to apply the profile to, and then we draw an area of interest. We can then give this a name, or if we just press OK, it will automatically name the profile for us. We can also put down circles. We can put down a freehand area. And you can put down polygons, which are a number of, we can also put down polygons, which are a number of straight lines in position there. We've also got the ability to copy a profile, so I can pick up a circle and then make copies of this around areas that we're interested in. We can move a profile, so I'll move this rectangular profile to a different area. You can rename a profile, so this one was originally called OAP12, we'll call that test. And if you find that you put something down that you don't want, you can delete it. Again, select the window and click on the profile that you want to delete. The profile is highlighted as a green colour when it's selected. We can also resize profiles. Select the window, select the profile, and I can make this bigger. We can rotate a profile. And we can edit points on the profile to distort them. Odd area sets can also be saved to disk for future use. To do this, you go to the Save OAS icon, select the window with the odd area sets that you wish to save, and then give it a name, and I'll just call it Test. Once all of the profiles have been applied to the image, and there's no real limit to the number of profiles that you can have on any one image, you can then extract the data associated with that set. And to do that, we go to the Extract icon, we select the image that we want to extract the data from, and then the Odd Area Set Statistics window is opened, which shows us each of the names of the odd area profiles and the various statistical data associated with each of those areas. Sometimes it's useful to limit the amount of data to one particular type of data that is extracted from the odd area sets. To do this, we go to the Measure menu, select Options, select the OAS tab, and if we then put a tick next to the Extract Single Data Item Only, we can then select what information we want to provide in the statistics. And what I'll do is I'll select the mean intensity and press OK. So if I now extract the data again, we now just get the odd area profile and the mean intensity associated with each of those areas. It's also useful to be able to delete the odd areas from the image. Now I haven't got an icon set to delete all of the odd areas, but if we go to the measure menu, select OAS, we can then say delete OAS, and again we select the window, and that will remove all items in the odd area set. Sometimes it's useful to be able to automatically define the odd area sets in the image. Before we can do this, we need to create a binary mask containing the data or profiles of the image. We do this by going to Operations, Enhancements, Threshold. At this point we're asked to select a source image which holds your original data and a destination image for the new binary mask, and we'll put this into image buffer B. We're then presented with a slider bar that generates a set threshold, and I'll just set it to this point here. So we've now got two images, one containing the original data and one containing the binary mask that we were going to automatically detect the areas from. So I then go to the measure menu, select odd area set, odd area profile, and select area scan. And we now select the thresholded image, and it will automatically find each of those areas that are highlighted. Now there's another function which we haven't yet talked about, which allows us to copy an odd area set from one image to another image. So we can click on the copy icon, select the source image, which in this case is the image from the threshold mask, and apply that to the real data. And now, having done that, we can then extract the data from the image, and this gives you a much more accurate and tightly bound mask. So far we've just looked at applying odd area sets to single images. It's also possible to apply and treat odd area sets to sequences or stacks of images in exactly the same way. Now what I've done is to generate a sequence of images which I can now play through based on the original data that we had in the clock file. We can, just as we looked at earlier, copy the odd area set from the mask image onto the data, and we can extract the odd area set data. Now if I just select the image window itself, it will extract the statistical information, in this case it's showing the average intensity in each of those areas, for the frame that is displayed in the image window. However, if I select the image button, and this is the button with the little sprocket holes indicating the sequence image, it will apply that odd area set mask to all of the images in the sequence. And in this case we've got 70 images, so we get the 70 sets of data. Now this file can then be saved, and you can load it into Excel or any other analysis program for any further analysis work that you wish to do. Sometimes it's useful to be able to have a graph bound directly to an image window. This allows multiple graphs and images to be maintained within the application program. To do this, we need to make a change to the system preferences. We go to the File menu, Preferences, and the View tab, and then we will select or deselect Graphs in Graph Window. Now what this is going to do is to send the graphs directly to the image window rather than to a separate graph window. So I'll now press OK. And if we now do Line Profile, we select the window, we draw the line onto the image, it now opens the graph directly in the image window, and we can toggle between the image display and the graph display using these icons down at the bottom of the window.